Good day, everybody. My name is John Winkowski, and today I'm here to tell you about the star Betelgeuse. Now, we talked a little bit about Betelgeuse in our Orion video from last week, but this star is so fascinating that I felt like it deserved a video of its own. So let's head on to the planetarium and take a look. All right, let's bring the lights down and take a look at the night sky. Now, our sky is going to look a little different from normal today because I've gone to the trouble of turning off all of the light pollution in northeast Michigan. And this is going to show us a night sky without any light pollution whatsoever. And light pollution is just what we call it when lights on the surface drown out the lights from the stars. Here in Alpena, our light pollution is a bit dimmer than most cities, but turning off all of the lights will make our lesson a little easier, as Betelgeuse, and all of the stars for that matter, will be a lot easier to see. I'm going to change our view now, just so that we're centered on Betelgeuse, so bear with me as the dome reorients itself. And inside the planetarium, some people have to close their eyes while this is happening, but hopefully it doesn't work that way in the YouTube video. Okay, so it looks like we're centered. So let's do a quick refresher on how to find Betelgeuse. Now, Betelgeuse is just the top left star in the constellation of Orion, and it can normally be found, or always be found for that matter, a bit up and to the left from where Orion's belt is located. So to put it in the simplest terms, look for Orion's belt, and then try and find the orangish red star a little bit above it, and more than likely, that's going to be Betelgeuse. Okay. Now that we remember where to look, let's focus on the star of today's show. Betelgeuse is fascinating for so many reasons, but let's start with what makes this star so noticeable in our sky. That is, its brightness, size, and color, all of which make it easily visible whenever it's out. Betelgeuse looks this way to us because it's what's known as a red supergiant. This just means that Betelgeuse is several hundred times the size of our sun, and it has turned a reddish color as it nears the end of its life. While the star may be much bigger and brighter than our sun is, it's actually a bit cooler than it. And this is going to sound weird at first, because red stars are actually the coolest, while blue stars are actually the hottest. As you can see on this chart right here, you can see that the blue and white stars are really hot, while the more yellowish orange ones are really, really cold. This seems a bit opposite of what we're used to here on Earth, as when you want hot water, the handle is usually colored red, while cold is usually blue. I find that it helps to think of stars like giant balls of fire, as blue flames are much hotter than their red or orange counterparts are. This analogy helped me understand this aspect of star temperatures, and hopefully it can do the same for you. But let's get back to the size of Betelgeuse though, because earlier I mentioned that it is several hundred times larger than the sun is. That size sounds impressive, but it may be hard to visualize. So I've created a scene with my planetarium to help our brains better understand just how gigantic this star is. All right, so what we're observing now is a representation of what our solar system would look like if we could put Betelgeuse directly where our sun is located. This large red sphere towards the middle of our screen, that represents Betelgeuse, while the small yellowish ball at its center, that's our sun. And if this is not overwhelming enough for you, these small 4 circles inside of Betelgeuse, those represent the entire orbits of the first 4 planets. This means Betelgeuse would completely absorb Mercury, Venus, Mars, and yes, even Earth if it suddenly replaced our sun. And this 5th circle, just barely outside the range of Betelgeuse's surface, that is Jupiter's orbit, which lies about 500 million miles away from the sun. This is the type of size astronomers are talking about when they say supergiant stars. Behemoth stars so big that they would devour an entire solar system. While supergiant stars are awesome, they have a serious drawback to their size. And that's the fact that they have really short lifespans. Well, at least for stars. You see, for a star to be as big and burn as brightly as Betelgeuse does, the star has to burn a whole lot of fuel. If you think of it like a vehicle, a star like our sun would probably be your typical sedan, while Betelgeuse is a gas-guzzling monster truck. And the issue of this is that stars don't have gas stations. So once their tank gets empty, they're out, and they become permanently extinguished. And when a star like Betelgeuse runs out, it's going to go out with a bang, a supernova bang, to be more precise. Now, a supernova, what we'll see kind of a visual representation of what that looks like here, is, well, it's what happens when giant stars like Betelgeuse run out of star fuel. These bright explosions are insanely intense and powerful, even getting bright enough to outshine their entire galaxy. To put that in a more understandable perspective, our Milky Way has around 250 billion stars inside of it. And when Betelgeuse blows up, it will momentarily outshine the other 249 billion some odd stars in our galaxy. Supernovae are like the greatest fireworks show in the universe. And here on Earth, we're going to get a front row seat to the Betelgeuse fireworks extravaganza. Try saying that 5 times fast. Now, the bright explosion that will come from Betelgeuse's supernova may end up looking kind of like this in our sky. Although, to be honest with you, I've made that circle a bit bigger than it likely is in reality, just so that you can see it better from home. Now, a brilliant light like this will take Betelgeuse's place in the sky, outshining every star and planet visible from the surface of the Earth. This spot will be so bright that only a full moon and the sun will be brighter than it. This supernova will shine so magnificently here on Earth that it'll even be able to cast a shadow. This light will linger in the sky for years, slowly fading and dimming, but still remaining visible to the naked eye. This explosion will be so intense that we will actually be able to see it during the daytime as well. And let's kind of take a look at what that will look like. While daytime viewing of the supernova won't last as long, we will still be capable of seeing a sight like this for at least a year after the initial explosion. Supernova of similar brightness have happened in human history before, although we don't believe any have been as bright as what we expect from Betelgeuse. We can't say for certain when the bell will toll for Betelgeuse. We can at least be sure that it will be a memorable conclusion for that star. An astronomical event like this will certainly go down in history, much like other bright supernovae have in the past. It's also almost guaranteed that the Betelgeuse supernova will become a significant cultural event all across the globe, sparking the imaginations and emotions of everybody who can see it. The major downside to this beautiful and amazing celestial event is that there is pretty much no chance that anyone alive today will live to see it. Astrophysicists have predicted that Betelgeuse will go supernova sometime in the next 100,000 years. This means that the odds of it happening in our lifetime are so close to 0% that they might as well be. Maybe we'll get lucky though, and a bright star supernova from a similar star will happen in our lifetime, and we'll be able to see it while we're still around here on Earth. Since we can't see Betelgeuse's supernova in our lifetime, what type of celestial events would you like to see? Make sure to leave a comment on the video with what your answer or questions you may have. All right, everyone, I'll see you next week for the next video. Bye.